Hello friends, my name is Bilal Khan and this is the second part of the Rust programming language that I will be talking about. And in the previous video I have shown you that how you can work with the Rust in the form of hello world, and I showed you a little bit on introduction of the Rust programming language. But in this video what I'm going to do, I will show you the data types that will be used in Rust programming language. I will also cover some of the constant variables, how to define a function, how to define the variables, and how to make the data type conversion. So these are some of the little bit points that I will be discussing, and I will be hoping that you will understand properly. But yeah, this is the points that I will be covering. So let's go to the screen. So as you can see here that I'm currently present in the Acceleradra dashboard, in which I will be writing some of the more concepts. So in the previous video I have shown you some of the concepts relevant to Rust programming language, that what it is and what are the problems that it solves. So now let's go to the what you can say the concepts that I'm going to be talking about are the data types, right? So let's write that Rust has different data types. Let's say Rust has the following data types, right? So let's discuss one of them, or each one of them one by one. So the first one is going to be the integer, right? So the integer are different of different types. So there could be the integer like i8, i16, i32, i64, isize. And similarly u8, u16, u32, u64. All right, so these are some of the integers that are present in the like Rust, and there are some other integers type of, but they are increased. I'm not going to be discussing all of them. So let's there is another integer also by the name of usize. So yeah, what each of these integers are, and what are the limitations of it, and how you can count those limitations. So basically the integer i8 means that it will cover, or it can represent both the negative numbers and the positive numbers. So the i8 or i16, i34 or i64 or isize, they are basically the signed integers that can represent both the negative numbers and the positive numbers. But the u8 is basically the unsigned integers. So the u8, u16, u32, u64, usize, these are all the unsigned integers that will only cover the positive numbers. All right, so if you give them this like the negative numbers, they will give you the error. So yeah, so let's go to the what you can say, I will not go to the screen first of all in order to show you. Instead I will define all of these variables. So there is another variable also that is by the name of isize and usize. So isize is not covering any kind of bits, like just like the i8 is covering 8 bits, 16 bits, 32 bits, 64 bits, but the isize and usize are not covering any kind of bits. Instead their size depends on the architecture of the machine, that what is the architecture of that machine, whether that machine is 32-bit machine or the 64-bit machine. So if the machine is 64-bit, then the variable size will be 64-bit. But let's say the type of the machine is 32-bit, then obviously the size of these integers will be 32 bits. So yeah, it depends upon the architecture of the machine, that what architecture it follows, whether the architecture of that machine is 32-bit or 64-bit, and depending on those architecture, the isize will be like arranged according to that. So I will be showing you the example of it, but first of all let's go to another variable that is going to be the string. So string is you may be aware of that inside two double quotes, what you will do, you can simply write a string. This is a string, and you can print it. But there are some other points also in which the strings will be defined in different ways, like toString, string reference, and string from new. So these are some of the things that I will be discussing in details in the upcoming videos, but you just need to keep in mind that this is a string and how you can define it, right? Now the next point is basically to write the floating point. So the floating point is basically to show the decimal numbers or to show the numbers like this, right? 23.64. So the 65.65 is basically showing the decimal or the numbers that are basically like they will show you the floating point number in the form of this number, right? So it is not the exact 23. Instead there are some other percentages also, like 64, 50, 56 or any kind of number, right? So this is a floating point. So what is the floating point data type? So it will be either F32 or F64. Now the fourth data type is basically the what you can say Boolean. So Boolean you may be aware of it is simply true or false, right? Either the value is true or either the value is false. The next point is basically the data type is basically what you can say is the array, right? So this is an important concept in which you will be storing multiple values in one single variable. Like how you can do this, you can simply write like array a is equal to, and it will simply be written like this. As you can see here, there are 5 numbers that are stored in a variable, right? And you can simply print them out, or if you want to print them all, or if you want to print a specific array, you can also do this. Now the next data type is slice. So what does it mean? So basically slice means that it will take only the specific number from that array. Let's say if you want to take a this is the syntax of it, right? So let's say slice or s is equal to %a, and from 0 to what you can say, this is the 0, it will be starting from 0. The counting or the index will start from 0. So 0, 1, 2. So I want to print out the what you can say from 1 to 3. So what I will do, I will write 0, 1, 2. So I will write 3 because I also want to include 3, and that's the reason the fourth will be ignored. So 0, 1, 2, 3. So the 3 is basically the number that will be ignored, and it will only take the number from 1, 2 and 3, like because the index is starting from 0, right? So that's the reason the last number will be ignored. Now the seventh data type is basically going to be what you can say tuple, right? So tuple is basically nothing, is basically an array of different data types of variables. Like you will take different types of variables, like someone will be string, another one will be boolean, another will be floating point variable. So there are multiple data types that can be stored in one variable. So what do I mean by this? So let's say t is equal to, I will write like this is the integer, this is a string, this is the boolean. So as you can see here, there are 3 data types that are stored in this one variable, and you can use them. So yeah, this is basically the tuple. Now the 8th point is basically the character. So character is basically storing one character or one alphabet, like A, B, C, D, E, F, like any one character that you want to save. So yeah, this is what the what you can say the data types that are present in the Rust programming language. So let's show to you one by one in this Rust playground. So I have already written some of the things, like first of all, let me just remove all of them. Now if I want to refresh this, it will give me nothing. So yeah, now what I need to do, I will first of all write a function. So how you can define a function? You can simply write fn main, and inside this this will be the curly braces, and inside this curly braces what you will do, I will like, let's say I will like execute it for you like this. Now it will be easy for you to see it. So fn main, and inside this main what you will do, I will start from the first variable that is going to be the integer. So how you can define the integer, or how you can define a variable as a whole? So this is the syntax of it. So let variable name, and after that this is the colon, and this is the data type, right? So data type is equal to value. So yeah, this is the like the way through which you can define a variable. First of all, the variable name, then the data type of the variable. It could be integer, boolean, floating point, any kind of variable data type, and then the value that you will write. So let's comment it, and now let's write what you can say, let integer. So I will start first of all from the integer. The integer size is going to be u30 or u8. So after that, what I will write, let's say 50. So yeah, this is going to be the integer value 50, and if I want to print it, you will simply see integer. Yeah, this is the print statement that you can write it. This is the curly braces, and this curly braces basically showing that this integer will be stored inside this print and it will be printed here, right? So let's run this function. You will see that this is the 50 that is written here. So there are some points that I'm going to be discussing, is that what is the limitation of u8, and when is the time if you want to increase it. So basically, if I show you in simple words, like basically 2 raised to the power of 8 is basically will give you this result 256. So now the limitation of the u8 is basically 256. So any number that is below the 256 will be accepted, but any number that is equal to 256 or above the 256 will not be accepted in case if you are using u8. So I hope you understood. So this is also the point that you need to keep in mind if you want to check out the limitation of it, that what is the limitation of any kind of integer value that I'm using. So from in the case of unsigned integer, this is the formula of it. So if I show you here, like if I simply copy this, and if I print like what you can say, like this, let me just remove this, and now you can see here 256 will be accepted, below the 256 will be accepted, and above or equal to 256 will not be accepted. Why the equal to 256 will not be accepted? Because the index is starting from 0. So that's the reason the 256 will not be accepted. The 255 will be accepted, and the 254 will be accepted, and below it, but the 256 and above it will not be accepted because the index is starting from 0. So let's go to the playground. Let me just show you. Let's say if I write 256, exact number, right? So it will not be accepted because the index is starting from 0. As you can see here, that the literal out of range. So similarly, if I write 5, you can see here it is accepting it, right? So now let's say if I want to write, let's say 16, then what you need to do is to simply write 2 raised to the power of 16, and then it will give you the limitation of it. So let's take it like this. Let's put it like this way. All right, now you can see here this is the limitation of it. So if I print this, copy this, sorry, and if I write this, it will be it will not be accepted. Why? Because the last one should it should minus the last one, right? That's the reason. So let's run this in case if it is accepted. As you can see here, it is out of range. I need to remove one number from it. So like from 6 I will write 5. All right, so yeah, I just wanted to clear that what will be the result of it. So any number below will be accepted, but any number that is above it or equal to will not be accepted, right? So this is the case. Now in other cases you can also write it like 2 raised to the power 32, 2 raised to the power 64, and so on. So yeah, this is how you can check that what is the limitation of the unsigned integer. But let's say if I want to check the limitation of the signed integer, because the signed integer also covers the negative number and the positive numbers. So what is the checking process of it? So the checking process of this is basically like this. So let me just write like this. It will be minus 2 raised to the power of 7 and 2 plus 2 raised to the power of 7 minus 1. So yeah, it will take the this number, like let's say if this is the number I8. So the I8 is the limitation of I8 is this one. So if I make it equal to, you like simply take it, paste it down here, 128. And if I write like 128 minus 1, 127. So yeah, it basically it becomes equal to minus 128 to minus to 127. So it can range from 128 minus 128 to 127, right? So this is the basically the limitation of it, and you can go on in I16, I32, I14, right? So let's check it out. I200, like, because the limitation is what I28, so it will ignore it or it will give me the error. So let's, as you can see here, string out of literal, because I have not put it like I28. Instead, if I write, let's say I29, it will still give me the error. So now what I need to do, I need to write like for 27. As you can see here, I27 is accepting because it is less than I28. So it will go from the I28 to I27 on the positive side, right? So if you subtract 1, 1, 1 from it, it will move towards the positive side until it reaches to the I28. So yeah, this is the formula that how you can measure that, how you can see that what is the what is the limitation of these integers and how you can count them. For unsigned integer, this is the formula. For signed integer, this is the formula, so that you can keep in mind. Now the next step that I'm going to be talking about is the U size, because I have already covered in that the U size or the I size is basically depends on the architecture of the machine, that if the machine is 32-bit, then the U size will become 32 bits, but if the machine architecture is 64-bit, then the U size will become 64-bit. So let me just show you, like integer 2 is equal to U size, and in this case what I will do, I will simply write 34. So this is basically the integer 2 that I have declared, and this is the U size of it, not an ordinary size like I8 or U8. Instead, this is the unsigned size, right? And I can also write like integer 3, that is going to be I size, right? So I size 43, right? So these sizes depends on the architecture of the machine. So let's print them out first of all. Like I will write U size. U size is going to be like integer 2, and then similarly I size integer 3. Right, so this is going to be the size values that are going to be printing here. So as you can see here, that these are the values that are printed out, but these are the values that are normally printed. But if I show you the size of these U size and I size, what you will notice is that, first of all, let me declare a variable that size of U size is equal to what you can say. I'm not going to type the data type. Instead, I will just write the variable. If you want to, you can simply write like this. It will also be fine. So yeah, size of U size is equal to what you need to do is to define std mem. You don't need to worry about it. I'm just going to share the what you can say std mem. Sorry, it is going to check the memory size of it. That what is the memory of it? Size of like this, and what you need to do is to like this. I think, yeah, size of, and then U size, and then like this. I hope this is correct. So let me just print this out. Print this out. Let's say size of U size. Size of U size. Size of U size. So let's print this out and see what whether it gives an, yeah, as you can see here that it is giving me the size of U size equal to 8. So why it is giving me the size of U size equal to 8? Because it is in bytes, not in bits, and bytes are bigger than bits, right? So if I take this bytes and like take this 8 bytes and multiply this to 8 bits, then what it will give me the result 64. Right? So yeah, this is the 8 bytes and I multiplied it with 8 bits and it gave me the result 64. So that's the reason that I'm running the 64 bits machine, and this is the reason that the U size is basically equal to 64, right? And similarly, if I want to write like this and like this, and now you will see I will change the name of it, I size. This is also going to be the I size. This is going to be the I size. Let's change this to I size. I size. And now if I multiply this with 8, you will clearly see the result like this. So now if I, let's run this again. Sorry, the mismatched size of I size. Where is the problem here? So yeah, now I solved the problem. Basically you need to remove these annotations because both of them are treated as U size. So but if you want to convert them to I size, you can also do this. Like you can simply write like as I size. You can also write like this. And if you want to keep the annotation, you can also keep it like this way, and this way the U size will be converted to I size. But as you can see here that it is giving me the message like 64 bits. But let's say if you don't want to keep this annotation, you can simply remove all of them, right? So this will also work fine, right? So now it will also give me the same message, right? So basically I converted the U size to I size by using the as I size method like written here, right? But I removed it because I don't need it, and this is a simple method through which you can identify that what is the size of these U size and I size. Now let's get into this. Integers are covered. I hope you understood. And the floating point can also be identified like, now the second point is basically the floating point. So if I write comments here, so floating point, right? So this can be identified like this. So now the next step is to write floating point is equal to F32. And now if I write 50 like this, 43.54345, this will be the floating point. And if I want to write this, how I can do this, I will simply write like this, semicolon, colon, then dot, then 2. Means the two numbers from the right side will be taken, 5 and 4 will be taken, and these numbers will be ignored. Let's say if there are hundreds of numbers, then all of them will be ignored except these two numbers, right? So yeah, so let's take them like floating point like this. Floating point, as you can see here, 43.54. All of these numbers are ignored. And if you want to check the what you can say, the range of this floating point, that what is the range of this F32, then there is a formula for it, that is basically for 3.4 minus 3.4 multiplied by 10 raised to the power of 38 to 3.4 multiply by 10 raised to the power of 38. So yeah, this is the what you can say, 10 raised to the power of 38. This is the formula of it through which you can identify, but it will become a huge number. So you can simply like print here. If I show you here, like you can simply go here, print this out. Now you can see here this is a huge number, and you just need to understand that how many values it is going to store. So from minus this to plus this, it will store the values. Now let's comment this. Now the next point is basically the integers are covered, the floating points are covered, the strings should be covered, because here in the Acceledraw I mentioned the string first and then floating point. Now let's discuss the string var, and now the the data type is going to be string. So there are multiple data types that you can write, like you can write a reference to str like this, or you can simply write like string, right? So but here you just need to remove this, because I'm not going to go deep into this side, because there will be a ownership borrowing concept come in between. I don't want to make it too complex, but you just need to keep in mind, you can simply write the data variable name is equal to, without mentioning the data type, and write this is the string, right? So if I write the print line like this, string variable, as you can see here, this is the string, right? So yeah, I hope you understood that how you can write the string here. Now the next point that you need to keep in mind is integer, string, floating point, and then the boolean. So boolean are the same. So boolean val, boolean variable, data type, what you can say, bool, and let's write true, and simply write println boolean variable like this. Now if I refresh this, run this, you will see that this is a true statement that it's showing me. Now the next point is basically the boolean is covered. Now let's write the array, right? So array, let's write like this. Array is going to be there are two data types that will be mentioned in the array. Like the first one is going to be the size of what you can say, the data type of the array, that what is the data type of the array, like 32, 8, or any kind of array, U8. I will mention the U8, after that semicolon, and then the size of the array, that how many values you are going to store in the array variable. So I'm going to store 4 values. All right, so let's check them out. So 1, 2, 3, 4. These are the 4 values that will be stored inside this array, and each of these what you can say values are going to be of 8-bit integers, unsigned integers, right? So let's print them out one by one, or if you want to, you can also do this like what you can say, sorry, the internet connection is gone, so I will keep this and move to the what you can see Visual Studio Code. But yeah, first of all, what you need to do is to mention the array, and inside this array what you need to do is to write what you can say, this is going to be identified as index 0, 1, 2, 3. So 4 will not be counted, so it will start from 0, 1, 2, 3. So let's say if I want to write 2, then what it will do, it will not run because the internet connection is gone. Let me just copy this and open the Visual Studio Code, because the internet is gone. So let's remove this, all of them. So yeah, now let's save this, and I will remove this. So yeah, now what you need to do is to run this. So if I run this, cargo run, this is also the concept that you need to keep in mind, cargo run, right? So 3, as you can see here, 3 here. So 0, 1, 2. So 2 is basically showing me the number 3. So yeah, this is how it will be like sorted out. If I want to say 4, it will not be printed, because it will give me the error that cargo run index out of bounds, the length is 4 but the index is 4. So yeah, index should not be 4, index should be 3, the length is 4. So if I want to write 3, now it will give me the message 4, value 4. As you can see here, value 4. So yeah, this was my point. So let's jump into another point, that is basically the arrays are covered. You can write a for loop into it by showing all the numbers, but I'm not going to them because the for loop is in the video, is another video topic. So now let's define slice. So slice is basically what you can say is the portion of the array that you want to take, like few numbers that you want to take from the array, that will be identified as slice. So ampersand sign, then array variable, this is the array variable that I will be taking, and now I will take the values from 0 to, these are 2 dots, to let's say 2. So how much data it will take? It will take the 0, that is 1, 2, 1 and 2. All right, so it will ignore this 3 because it will only take 0 and 1. The 2 will not be taken because the index is starting from 0, right? So if I remove the index, like start from 1, then it will be 1 and 2. So 1 and 2. All right, so the 3 will be removed because the index is starting from 0. So let's write print line. In this time, if I write like this, slice, and let's run this. All right, now you can see here that it is giving me nothing. I don't know why. So I think that it should be written like this, colon and then question mark. As you can see here, the colon question mark is required in order to run the slice, and this is 1 and 2. And if I write 3, then 3 will be given and 4 will be removed. So 0, 1, 2, 3, 3. All right, so 4 will be ignored. So let's clear this. 1, 2, 3, and 4 will be ignored. All right, so the last number will be ignored because the index is starting from 0. Let's see if I want to include 4. Then it will start from 0, 1, 2, 3, and fourth one will be ignored. 0, 1, 2, 3, 3, and the numbers are given 4, but the fourth one will be ignored because the index is starting from 0. Now you understood what is what you can say integer, what is floating point, what is a string, boolean, array, slice, and what is the next point that I have written, like tuple, right? So I was not remembering. So yeah, tuple is basically taking multiple data types and writing them in one variable. So what do I mean by this? So here is the what you can say syntax of it. Let tuple is equal to, let's say this is the integer value, and this is the string value, and this is the boolean value. So there are three different data types values that are written in one variable. So how I can print this? I will simply write print line, and then what I will do here, I will simply write tuple, and this thing, the tuple will not be written like in the form of in this syntax, like 1, 2, 3. Instead, it will be written like tuple dot 0, and tuple dot 0 will print this 1. All right, so if I write like this, not a value. All right, so it should be true, not a boolean. So I hope you understand. There are some mistakes, but I like the approach of Rust that it gives me the instructions to improve it. So yeah, as you can see here, 1 is printed because I put the index 0. Let's say if I put the index like 1, then it will print me the string value. So let's clear this. As you can see here, string value is printed to me. So similarly, if I write 2, then it will print the true value for me. So yeah, this is the tuple, and now the next step is to write the character. So character are simple, so you can simply write character is equal to single quotes, and inside this, let's say GH or any kind of single quote that you want to write. clear this, and it will give me the message because I'm not printing it. So let's say print this like this, character. So yeah, you need to be caring about the Rust because it is really strict. So yeah, this is the G character that is printed here. If I remove this to H, it will give this H to me, as you can see here. But let's see if I want to write multiple characters, then I think that it will give me the error. As you can see here, that if you mean to write a single string letter, use double quotes. So it means if you want to write the string letter, then you need to write double quotes instead of writing the single quotes, because character the single quotes are for single characters. So yeah, it is really good that it is giving me each of the guidelines that what I need to do. So now what I need to do, these are the things that you need to keep in mind. After that, I will put all of these things in the GitHub. I will link them in the description below so that you can check them out. Don't need to worry about this code. Now the next step is to define the constants. So I have commented them all. Now the next step is to write the constant. So how I can do this? I will simply write constant. These are the values that will not be changed. So constant variable name, so that constant variable name, what you can say name could be should be written in the upper letter, not in the small letters, just like I have written here, right? So after that, let's say U8, right? And now not write U8, U should not be written in capital letters, instead it should be written in small letters, but the variable name should be written in the capital letters. Now let's write the U is going to be, let's say 140, and now this is the global variable that is defined like out of the function, right? Yeah, now let's write the function, and inside this function I will call this, I will print this variable name like simple, like this. All right, variable name. Okay, so let's print run this. Cargo run 140. So this is a global variable that you can use anywhere, right? So yeah, this is the point. Now the next step is to cover the, what you can say, data type conversion. So how to convert from one data type to another. So you can simply convert it like let's say main. This is another function, and inside this what I will do here, main, what I need to do, first of all write the floating point, sorry, let float let float f32 is equal to, let's say this and this, right? So now I want to remove them from the floating point. Instead, what I need to do, I need to convert this to the integer value. So how I can do this? I will write integer U8 32, and now what I need to do, I will write what you can say, float as integer. So basically it is taking that float, and as it is converting that float to this integer. Now when I will put this integer, like I will write this into print this integer, what it will do, it will give me the same numbers, but these decimals or these numbers after dots will be removed. So let's save this, let's clear this, cargo run, not found in this scope. Where is this float? Yeah, this is the point that I should remove it. Instead of writing like integer, I should write U32. Now this float will be converted to this U32 because I made a mistake. I wanted to convert this float to integer, but that was not possible. Instead, I should specifically mention that what is the data type that you want to convert into, right? So U32. I think that it will work now, right? As you can see here, 324 and dot, and these numbers are gone. So yeah, these are some of the lessons that I have taught you about in this video. So in the upcoming videos, I will be talking about more specifically relevant to functions and some of the other concepts. So I hope you understood that what are the data types and how you can identify those data types range. And I'm not going to cover all of these formulas. You can simply check out in the online or GitHub, what you can say in the ChatGPT, there are formulas for it. But I taught you like how you can specifically check the range of some of the unsigned integers and floating point numbers. But after that, I taught you that how you can work with Boolean arrays, slices, tuples. These are some of the concepts that you need to keep in mind because they are of daily use, right? And yeah, I hope you liked this video. So if you liked it, then make sure to subscribe to my channel. And if you have any questions, then ask those questions in the comment section below. I'll be happy to answer all of them. So till then, goodbye.